this is IBM Museum. And as it happens, I have some time that I'm just going through and slogging through data that I'm trying to compile. And this video will be covering a lot of that process. I went through last night, I was working on this, and it just wasn't coming out right. It was rather late when I finally made some breakthroughs, and it started coming together a little bit more, but too late for a video. So I'm going to go through on this video and show, with the test rig that's behind me coming up later, of going through and working with some of these adapters and showing just how I go through and work with some of this data. So the topic of this is going through for the TokenRing adapters that are, in this instance, capable of both the 4 megabit and 16 megabit data rates. There are other TokenRing adapters, of course, earlier TokenRing adapters being the 4 megabit models. They weren't able to do the 16 megabit transfer rates. And so this is not going to be about those earlier adapters because they have a different adapter ID. That adapter description file, or ADF, for the 4 megabit adapters is E000 hex. The adapter ID for the 16/4 megabit adapters is E001. So when I go through and I have my testing rig, I go through and I just configure it for one of the adapters. And I can go through and actually switch adapters of the same adapter ID without having to reconfigure the machine. That being microchannel, that means going through using the reference diskette on a lot of the earlier PS2s, or the IML partition, that convenience partition for configuring the system. In this case, I don't have to do that. And if I were to go through and do the 4 megabit adapters, and certainly I'll go through and address those as well at another time, but I would have to go through and reconfigure. And I would most likely do it just in batches. I'll go through and do the 16/4 adapters, then I'm going to go through and do the 4 megabit adapters later on. I'll just configure it for one of those adapters and run through those adapters just one by one to get the data. Now those earlier adapters, a lot of time, and I'll show you in just a moment, the microcode for that chipset, the TokenRing chipset that's on that adapter, it's often printed on the EPROM itself. And even for the adapters I'm going to show today, it's printed on there a few times. It's not always on there. And it's not, you can have an EPROM of the same FRU, that field replaceable unit, all that number matches. In one case, the EPROM has that microcode version printed on the label, and other instances where it does not. I've got examples out that do show that, to at least confirm a little bit as I go through and test these adapters to show that. I'm also not working with the later adapters. There's even a real nice adapter called the Auto TokenRing adapter for microchannel, and it has the same adapter ID, that E001. It's a slightly newer ADF version, and that's a little bit of, I'll go through and the same thing. There's less to test in that regard with those adapters as far as a microcode version, and it should work even though it's a later adapter, and there's higher level TokenRing adapters that really came along later that really don't fall necessarily in the same scope as these do with the microcode. Now what I'm doing here, and I'll give the link to this in the video description of going through. Of course, I'm at the Ardent tool for the page on the TokenRing adapters, so 16/4 adapter A's, and I'll show the long and short versions, but I'm going through down to a link here that is for the diagnostics, and I'll go through and work back to this page, of course, because it does show pictures of the adapters that I'm going through and working with. You'll see these on camcorder as well. I mean, it's fairly self-informative why these are labeled as the long adapters or the short adapters that they are, and you know, you'll see that when I bring up the adapters to the screen. But I'm going to go through and I'm going to go to this diagnostics, and that is you can go through and even download it yourself. It's on a diskette that the image is archived up at the Ardent tool, and it's going through and running this diagnostic program on the adapters. And so I'm going to go through, I'm going to go back to the TokenRing page, and we will go through and get the test rig in the background. I'm going to keep my webcam picture hidden for now, just so there's not any phase difference, and I do have the full display area that I can see when I bring up on the screen. So going through with an example that I have right off the top, and these post-it notes, this is not my handwriting, this is wherever I acquired this so many years ago. A lot of the time they'll have the labels of the adapters, and this is a particular longer plastic piece on the front of this, just to go through and make it so it fits in the guide and everything else. IBM didn't do this when they go through and have the short adapters. Now, typically a longer adapter that has a shorter version, that the same functionality, typically the long adapter comes first, and it's where IBM just shrunk down the PCB, retooled the design to have it fit in a smaller and smaller area. And in particular, in the 16/4 adapters, they have where they were putting all the TokenRing functionality mostly on a single chip, where there was discrete components. There was a separate CPU and transmitter and receiver that were on particular boards. In this case, there's even a secondary chip that still handles some of the interface to the actual port, but they've gone through and many of the components were reduced to that single chip. Now, there's even code names for these chips, and I'm getting to getting ready to send some adapters that will be disassembled, and I'll provide links and all that. The person I'm going to send this to, he's done disassemblies of these chips in the past and gone through to where some of the encodings are visible die, and it's really some kind of cool stuff. I was just looking to see what the identification on this, and this is probably one of the spyglass variants here. I have other examples. Now the example adapters that I brought out, they some of these EPROM labels are kind of chewed up compared to others that are more pristine condition, but of the same versions. But I went through to select the adapters because there is the encoding where they went through for the microcode versions. And what I'm doing is I'm working from this FRU. These are actually interleaved chips. One handles the high byte, one handles the low byte for that range of their functionality in the board. And so they're typically expressed as odd and even convention for if you have the FRU of the one that's in the even socket has an even number to it. I don't know if it's visible, very visible there, but that ends in a 3-1. And this is the odd chip, or the odd EPROM in this package. Now, at least we have a little bit of the feedback of what microcode version is there. And as I go through and run that diagnostic program, we see a little bit of that. Sometimes there's extra characters that are thrown in. I don't know if those are spurious at this point or not. So, I mean, very evident again, these are the long adapters. And each one of these has a different, EPROM version on them, even though they may be a lot of time the same adapter. They have the same IBM FRU, that field replaceable unit. That was where the engineer, knows that, hey, if he has an adapter that goes bad, he knows what he or she, to order to get an exact replacement for this. And IBM had engineering changes as well. If you find this FRU in the field, go through and replace it with this FRU, and was able to cover things. And those engineering changes, I mean, they have things like the bodge wires and other aspects too on as they went through and worked on things. It looks like both these adapters having the same FRU, have the same relative bodge wires between them. But this adapter, the second one I pulled out, does not in this case have that microcode. Have a version of the EPROM that lists the microcode. The code on these, and that was what I was doing a lot yesterday, is trying to make heads or tails of how if there's any human readable strings, if I could pull that version number out of there just by looking at the EPROMs themselves. And I have not been able to discover that so far. The other long adapters, in fact, we'll probably run this one since I don't know effectively or I didn't know the microcode version. We'll run through this one as a test. Excuse me. And a lot of these, it's going to be redundant. It's just putting the adapter. I'll go through a couple sequences of it. There's another one that we have the microcode version listed easily on there. And this spare socket, I've gone over these boards before. This is for what I refer to as the Ripple ROM, or RPL, or RIPL, Remote Initial Program Load. That it's a boot ROM. That's so you could go through and you could use this board to boot over the network. And IBM even went through at a later point where they put the Ripple code also within the EPROMs, the same EPROMs that had the microcode for those adapters. Like the short adapters I'll pull out in a moment will show that just by having the two EPROMs and not having a socket for that Ripple ROM. And then the last adapter I have, I think this is another one, all the examples I pulled out, it does have the microcode. They've got that EC, or engineering change level, and they've got that C2 24550. Now, in some cases, there are, in particular, it's documented at the Ardent tool that even notices of those engineering changes I say that came out. It let the field engineer know to look for particular FRUs and to replace them if there was problems with a particular, it's just basically a problem resolution method. We're going to do the long adapter there. I'll work over to the, and particularly the short adapters. A lot of time they didn't list the microcode versions on there. This is actually for the 02. Yeah, this one's nice because it's got this one is ultimately the Pine Grove chip on this one, and this is, if you can see underneath the labels, it's got a different FRU, that 50G, and this is actually the Pine Grove shrink chip that is a later, in other words, it's a revision of this chip that they shrunk down the die inside. And I'll give the links to Ken Sheriff's blog that shows him going through and the disassembly of these chips. He's going to get other adapters that he can go through and look at those as well. So the last one I'm going to cover is, I've gone over the trace and performance documents before. IBM went through and they have a program called the trace and performance. You could have an adapter in a system that ran a special program, and that told of the performance of the network. Kind of a larger scale diagnostic like I'm going to do that goes through and tests one board. This goes through, it was a sole use of using that system to go through and make sure that your network was running good, that you could see faults that would occur on the network, see how it was utilized. And they called it trace and performance. I've gone and read through the trace and performance documents before, but even these microcode versions, I mean, it has a version numbering on it, and just lost the label. I'll stick it back on later on. These short adapters, that's got the two EPROMs on it that has the boot ROM code within those two EPROMs as well, just to being able to reduce the space that of the PCB, reduce it in size, reduce it in components, cut down cost of making the adapter. And of course, they didn't extend a piece of plastic full length to have the guide when they came up with these short adapters. But let's go through. I'm ready to go with my test platform. And this is actually an aftermarket planer that's in here. This is the Reply Turbo board. And pretty high performance when you get into the microchannel. Relatively rare system out there, but it goes in place of, this is a Model 80 case ultimately. And I don't have any adapters, just I'm going through for the sole 16-bit slot. And I could go through and put this in the 32-bit slots as well, but I've got the machine, the 16/4 TokenRing adapters in that slot, and of course they're numbered from the bottom: 1, 2, 3, 4, 5. This is in slot 5, 6, 7, 8. 8 slots total. And I'm going to go through. I've got a hard drive configured, and up here in the bay I've just basically got some panels pulled off, of course. The front bezel, have a diskette drive with the diagnostic diskette for the TokenRing loaded here. And it boots from that diskette it doesn't boot from the hard drive in this case. And I'm going to go through. I will get myself back on this screen, just so I'm visible of what I'm doing with the system behind me. As you see it go through and boot up. And it's going through and booting from the diskette in the drive. Okay, so I'm going to latch onto the keyboard. And you have the ability to have two of the TokenRing adapters in the same system, identified as adapter 0 or 1. And of course, we just have the adapter effectively 0 in this case. So I'm going to press 0 on the screen, goes to the point of the okay. Oh, I guess that's helpful to show the error of why that error happened. And I was hasty. I went through, let me get switched over back to the camcorder view. I like these warts and all the things. That things happen and it gets an explanation. You wonder why I have the MAW here, the TokenRing MAW, that connects your stations together in there, and this cable. Because this is a critical thing for the purposes of this test, to have it, the adapter that you're trying to test, cabled into, from the adapter to the MAW, even though it's just one single station, to have that link up. And or you get an error, of course. So let me go through, Control-Delete. We will do a reboot, and I will get myself back on the screen here again. We'll see this time will be a little bit more successful when I have it properly cabled here. Okay. I think there's just a little bit longer for it trying to figure out things, maybe. I heard a click of the TokenRing adapter clicking in, so that's probably what it was waiting on. Okay, and again, we're back at the screen. We're going to press 0. We're not going to get the error message this time that we're connected to the, hear the click again of the TokenRing. And I'm going to press the F1 key to get the help screen up that gives the information I'm looking for. So I'm mostly looking for on this, it actually gives the MAC address in those first two fields, but I'm looking at that center line that has the adapter code level. And there's a number there. It's kind of in a different order, but that's the effective data of what that microcode version is. And so I went through and I even recorded that on a, I can show the chart. I'll go through and, you know, run through another adapter as well. But I went through and recorded it on this chart. And I've got both. In fact, I'll go through and hide my webcam. And so you see at the top, in the notes I've got where some of them are the 8-bit adapters that listed that microcode version on the EPROM, and we're more focused on down towards the bottom of the chart where I have the microchannel or that MCA adapters listed in a row, and I've got the EPROM FRUs listed there for both the odd and even columns, and then go through and I've recorded, I think it's actually line 15 is this particular one of the 2342279A is the version that I'm going through and testing in this instance. That looks like a match with that number. And then for the notes, I've got even I've got the chipset that's on that particular adapter. There can be sometimes an assortment of that integrated chip on there, whether it's the Spyglass or the Pine Grove Shrink. So I've got that, and then the note there of what adapter it is and things like that as well. So just going through and building some data, and I mean that's what I do. That's just going through and compiling that data and trying to make sense out of it after I have it. Now from this, I don't even have to go through and do the end or anything like that. I can just simply go through and it's not going to hurt anything. I just power down and go through, disconnect the cable, pull that adapter out. And this is the one that had, okay, that's why I get no signal, because go through and switch over just to the camcorder while we have the machine off. And this is, hold it up in the field of view I had. This is one where it does have the microcode version, that C24550. You know, remember that. Remember that version, because we'll see, you know, how that shows in the test. Go through, plug in the cable again, cycle the system on, and we'll get switched over. Okay, and we'll let things boot up. And this data, let's see where I've got that on line 18. I've got that C4550 for that particular version. And still, as you see on the notes on the right, that long adapter of what type it is. And okay, so we're pressing 0. We might be able to hear the click. Yep, as it goes through, and then pressing the F1 key. Sometimes it just takes a little while. And we see that on the screen, that C 24550, the same match of what's printed on the EPROM. So that's at least a little bit of confirmation. And as I say, I look for that sequence in the EPROMs themselves. And there's two EPROMs, and it can be that they need to be compiled together to interlaced in that sense, because you're seeing one byte from one of the EPROMs and then the next byte is from the other EPROM, and it goes through that whole space that they're on that way. It just alternates between which EPROM that next byte is on. It just goes back and forth for that entire space. So that may be it to kind of resolve that. There can also be some encoding sometimes that those EPROMs are in that can complicate things and just make you double check, and you're seeing all these just strange characters on the screen, and you have to make sense of it, like I was doing yesterday, and it just wasn't coming together. But we've got, that one tested. Let me go through. In fact, I'm going to bring up back to the web page. I'll go through and interact with it, just because I want to scroll down to kind of show there's you see things like this EPROM change for TokenRing adapter. And let me see if I need to move. No, I'm nestled in there pretty good. Well, let's just go through and do that. But so when they talk about the down level, IBM is disclosing a fault that has been reported, that they may show a particular thing. In this case, IBM is listing the problems that is encountered, and they it says look for EPROM part numbers, and it has that, the 74F99325 and the 9326. Those are the pair, basically, or the 25F9523 and 25F9524, or run Token Diagnostic from the reference disk and check for the microcode level of that C24550, which is one of the microcode versions that we just checked. So IBM is disclosing in this case, hey, there may be an issue if you have an adapter in this scenario set up as a server that shows these errors, and if so, you go through, and if you can't change the environment otherwise of how that adapter is being used, or go to a different adapter that's more appropriate to the server level, then you go through and change out that EPROM. And as we see in the text there, it says only PS2s used as servers operating with non-IBM network software are affected. Workstations which are not used as servers do not require new EPROMs. Replacement EPROMs are FRU part number 92F9122. I looked up that number. Normally it should be, that's the set, and that's probably why I'm not getting results, is that it's not listed as the set of EPROMs. If undoubtedly for some of the other FRU on the later EPROMs out there, in other words, there's some resolution. I'm trying to organize this by dates that are printed on the EPROMs as well, that those versions that were reported having that issue, it looks like that they're around the 1990 time frame, and there's some microcode versions that are later, and probably one of those or more than one in this instance could be just the replacements for those EPROMs. Those are later versions of the microcode that came out. So hopefully this has been just a kind of a good showing of the aspects that I do for, you know, the behind the scenes, as it were, I guess, of checking these things. And that shows up as well, of going through and going through and capturing those EPROMs, and even in the case where in this modern time frame, you could have an adapter with older microcode versions that you want to upgrade to a newer microcode or something like that. And heck, we'll have, you know, the image online. I go through and copy those EPROMs as well. And I've gone through and covered most of the EPROMs I've encountered from my adapters so far. And it's just going through and getting those linked. I was going to look for, because we're in the text, that there are, you know, based on the diagram, you can sometimes I'm looking for on this page. Okay, so there we've got the Ripple ROM for this adapter that's downloadable. In other words, if you need that EPROM image, you just download it from the Arden tool, burn it to an EPROM chip, and plug in the adapter, and you're good to go. As time progresses, we'll get links in there too that you can just click on that link for the EPROM versions, or even showing the different versions that may be on that adapter as well, that you can go through and get a later version. So, you know, I hope that this was a informative video, that you at least learned a little bit of the background of some of the things that I do to just help gather the data on these adapters and make sense of building these charts to figure out how these things work, to go a little bit further in understanding things. So, but so I'm going through, you know, these are the videos that I've gone through from the time after, you know, last Saturday I was off in Dallas, Texas, visiting Computer Reset. In fact, I was actually waiting for the LGR video to drop. Clint went through and he released another video today, but it was like a mouse keypad. And I'm sure within the next day or so, maybe before tomorrow morning, he'll have dropped that video. I may be even on that video sequence. During the time he was recording, I was moving around the building, shopping, as were others, and got a chance to meet him and Dave Murray, the 8-bit guy there at Computer Reset. But I'm having a live stream tomorrow morning. I'm resuming my live stream schedule, and I do that at 10 a.m. my local time on Saturdays, which is GMT -7. And that resolves as noon Eastern Standard Time and 11 a.m. for Central Standard Time, and then 9 a.m. in Pacific Standard Time. If you're outside the continental United States, that GMT -7, I do that's 10 a.m. Is, you can calculate when that is. But of course, I've got a link. I'll go through and link that in the video description of my first post-trip from Computer Reset live stream, and people are already signing up. I hope to have a lot of participants, and I'm going to go over aspects of my trip, and at what point some of those items will come out and be on video as well. That I won't have this stuff that work on the other times and compile for these videos. So I'm looking forward to seeing people there. There is a reminder that's advertised for my channel. You just click on the reminder, and that way YouTube reminds you when it goes live. It even has a little countdown timer and tells you how many hours are away to going live. So I look forward to seeing people there and going through for what I brought back from Computer Reset. I'm not going to probably even change the set. I can't have all those items. I mean, it's just an immense group of items, but I can start talking about how my visit was there as they go through and they wrap up operations, hopefully in April, to going through and selling the building, and that this era will, with them will be complete at that point, where just one of the other things that will fade in or fade out in history. In the Dallas community, there's a lot of retro computer people and everything else. I'm sure that the store will be missed in that regard, but at least they're going through this process of the items going through, and you're able to go in on a planning for a schedule, signing up for a schedule to go through there that they have on weekends. They have to work around other events, of course, that may be happening, but going through, and there's only a limited amount of weekends that are, that we're going to have before April. So I'm certainly recommending people to do that if they're able to go for a visit, to sign up. You got to follow the process of how they have it structured, but going through for paying that flat rate and being able to sort through items and get them. And I certainly plan at least one more trip. If not, hopefully I can do 2. I think 3 is a little bit too much, but looking forward to going back at least one more time before they close, just to kind of wrap up if there's anything else. But I look forward to seeing you tomorrow on the live stream, and I'm open to questions of what I'm going to, I'll have to find out how I'm going to answer some questions. There's some aspects that I've got to be careful around, but you can ask the question and everything else in chat, and so click on that reminder, get the notifications. If you thought that this was a informative video, go ahead and click on that like button, please. You enjoyed watching me going through some of the things that I do. Click on that like button and subscribe to my channel if you have not done so already. Recommend it to your friends that may be interested in this sort of content, so I can gain more subscribers too. We're on the final stretch to 1,000 subscribers, and certainly I want to go over that, but that's a landmark with the YouTube channel of going through in your first 1,000 subscribers. So I look forward to seeing you there on chat tomorrow, but this is IBM Museum. That's all I have for now. Thank you.